Tsunami is a Japanese word meaning for harbor wave. But what is a tsunami? A tsunami is a large ocean wave usually caused by an underwater earthquake or volcanic explosion. Tsunamis are not tidal waves. Tidal waves are caused by the forces of the moon, sun, and planets upon the tides, as well as the wind as it moves over the water. With typical waves, water flows in circles, but with a tsunami, water flows straight. This is why tsunamis cause so much damage. But wind generated waves usually have periods or time between crests between 5 and 15 seconds. Tsunami periods normally range from 5 to 60 seconds. Also, wind generated waves break as they shoal. Tsunamis increase in height as they go over gradual, long slopes. This is known as shoaling. The shoaling effect is what causes waves with the height about 1 meter in the open ocean to be able to reach 10 seconds or 100 seconds of meters above sea level or onshore. But how are tsunamis generated? Tsunamis are generated by any large, impulsive displacement of the sea level. The most common cause of a tsunami is seafloor uplift, associated with an earthquake. Can strike slip horizontal motion earthquakes trigger tsunamis? Yes, approximately 10 to 15% of damaging tsunamis are triggered by strike slip earthquakes. This type of earthquake is less likely to trigger a tsunami than one with vertical motion. The waves are likely generated by associated landslides or motion of a sloping bathymetric feature. Tsunamis are generated by strike-slip earthquakes, normally affect regions near the source only. Tsunamis are also triggered by landslides into or under the water surface, and can be generated by volcanic activity and meteorite impacts. Tsunamis are generated from the epicenter of the earthquake, and from there the water waves travel until it reaches the coast. In here we can see how the water waves are traveling, caused by the first epicenter, caused by the earthquake. Tsunamis are usually a series of waves, and the first one isn't always the most substantial, which is the reason for why a small tsunami at a shoreline can turn into a giant wave at another. Sequential peaks can be 5 to 90 minutes. In the first lap, we're going to be using the turbos from a pool to simulate the force from the epicenter of an earthquake. The water travels in the waves until it reaches the end of the pool. From the laps, the results that we obtained were 17 gallons per minute and 10 feet per second. In the second lap, the cardboard demonstrated the force of the earthquake. And then it is visible how the waves are created and they're traveling until they reach the shore, in this case, a piece of cardboard. The first of the four steps in tsunamis is a tectonic displacement, which causes a lot of water to generate massive amount of energy. The second one is the building. It creates progressive oscillatory waves. Then after that, they travel and the wavelength of the tsunami grows. The fourth is the approach. The tsunami slows down because of the land and the friction of the collision with seabed. And last, the impact.